Python algorithms. Introduction. This is a simple algorithm that does exactly what it says on the tin. It sorts a list of elements into ascending order. Bubble sort. The bubble sort is a simple method for sorting an array of data items. It works by iteratively comparing each element to its neighbors and swapping them if they are out of order, until all the elements have been compared and placed where they belong in the list. Bubble sort has good performance characteristics, but it can be quite slow when the number of items in your array is large. Quick sort. This algorithm is based on an idea called radix sorting, which was introduced by Georges Conti in 1885. It's based on recursion. The process repeats itself until no more iterations are needed. In this case, we use a binary search tree, BST, as our means of storing information about which nodes need processing next. This allows us to do recursive calls while maintaining efficiency while still being able to handle large amounts of data very quickly. Merge sort. Merge sort is a recursive algorithm, meaning it uses the same process to perform each step. It's also divide and conquer, which means that it divides your list into two parts and then recursively sorts each part separately. Finally, merge sort is an in-place sorting algorithm. It doesn't need extra storage space for intermediate results or anything like that. Just a test. In this section, we'll be taking a look at how Python works. We'll be writing code that uses the following functions. Len returns the length of the string, the number of characters in it. Count substring returns an integer indicating how many times substring appears in string. Reverse a string. Conclusion. The read and write times of the algorithm are affected by many factors, including data distribution, the size of a file, and the complexity of an algorithm. The main takeaway from all this is that any given algorithm may be faster or slower depending on these factors.